Okay, so when we graph a cycle of a trig function, you can bounce back and forth between the key features. I'm going to do most of the key features and then save domain and range for the end. So your amplitude comes from the front, and I crossed it out so you can't see it, but let me redo that. So the thing about the amplitude though is it's always positive, so that's 2. That means that it's going to go up and down 2 from the midline. Your period is found by using this formula. It's 2 pi over b. Now the thing about this period though is 2 pi over b. All you got to do is plug in the b, and b comes from the number in front of this x right here. So that means that it's just going to be 2 pi over 1, which is just 2 pi. Let me erase this stuff so we can see the problem. And then we're going to have, let's see, the midline. So the midline comes from the number that's at the end over here in this area, and it happens to be 0 because there's nothing there. So that means our midline is y equals 0. So I'm going to take that information and put it onto the graph. So start with the midline first always. Then we're going to mark off the amplitude. So it's got to go up 2 and down 2. And usually a sine graph, it's going to have 3 dots along the midline. So one starts at the origin, one in the center, and then you got the one at the last marking on that graph that I gave you. Now this negative means that the graph is going to flip upside down. So in this picture, usually a sine graph has the high point between the first 2 dots. It's actually going to have its low point between the first 2 dots because it's inverted. And then the high point is going to be at the end in between the last 2 dots. So our shape's going to go something like this. Now keep in mind the shape continues past these dots. It's just that that's all we want to show because we were asked to show one cycle in the very beginning. So the domain, the nice thing about these graphs is they go left and right forever. So the domains to all sine and cosine graphs are negative infinity to infinity. And then the range is just from the bottom to the top, which in this case, the lowest point is -2. The highest point is at +2 for the y values. And that's what you use for the range. Now, as far as even and odd goes, you have to kind of consider the entire picture. Just in general, though, I'll tell you this. All cosines are even. And if a sine passes through the origin, it's going to be odd. So that means that this one right here is going to be odd. If your sine pattern moves away from the origin, that just means it's neither now. Okay, next question. Same type of strategy here. We're just going to use 3. Oh my God. We're going to use 3 as the amplitude. So 3. And then the period is still going to be 2 pi because that's what happens anytime you have just an x inside of here. It's just 2 pi. Your midline this time is going to be at -1, so y equals -1. And so that means that when we start our graph, we always have to start with the midline. That's the first thing we put onto the graph every single time. Then we go back and we put the dots for that shape. It's a sine shape, but before I put my dots, I got to mark off how high and how low I need to go. The amplitude is 3, so that means that from the midline I go 1, 2, 3 down, puts me at -4. And then 1, 2, here's 1, 2, 3 up, so that puts me at 2. So as far as the dots are concerned, it's a sine shape. So again, we're going to have 3 dots along the midline. And since there's no negative in the front, that means the high point falls between the first 2, and the low point happens between the second 2. So it goes like this. So again, this one should be relatively easy. Domains never change on sines or cosine. They're always negative infinity to infinity. And then your range is the low point to the high point. And they're always going to have brackets. Even, odd, or neither. So cosines are always even. Sines are odd as long as their dot hits the origin. So this one, the dot is not at the origin, so that means that it's going to be neither. Now this next one, they've already got the information in there for us, and honestly, like when I do this problem, I don't really pay attention to the entire table. All I look at are these. Those are the only ones I really care about. So as I look at the graph or the actual table, the pi force, I'm not even going to bother with that one. I'm going to use pi halves. That's a good one. I'm going to ignore this one. I'm going to use pi because that's on the axis. I'm going to ignore 4 pi thirds. 3 pi halves is there, and I'm going to ignore 11 pi sixths. So this graph, all you do is regular graphing. We got this right here, 0, 2, and then at pi halves it drops down to 1. Then at pi, it goes to 0. And then at 3 pi halves, it goes back up to 1. And then at 2 pi, it goes back up to 2. So that means that it looks like we have a shape that does something like this. That was awful, but that's, you know, hopefully you get the point. So we have to come up with all the information based off of this picture. So first thing is identifying the midline. So the midline happens anywhere where you can locate the spot where it's the same distance above and below the line or the curve. So that means that my midline should probably be right here, since we go up 1 and down 1 from there. So that means that my amplitude is 1. My period, the period is where the 5th dot lands, so my period is going to be 2 pi. My midline is the green line that I drew, so that's at y equals 1. And then my domain, we should never miss a domain question on these because they never change. And then the range is from 0 to 2, lowest to highest. This shape, if you notice, the midline, let me pull these dots up again. There's only 2 dots on the midline, so that indicates that it's a cosine, and all cosines are even. Okay, next, cosine. So same type of deal. Amplitude is found in the front, so the amplitude is 2. Now the period, we're going to have to do the formula. The period is 2 pi over b, and this time the b is 2, so I'm put a 2 in here, and so that means these cross out. So that means that the period is just pi this time. Your midline is the number at the end, so that's going to be y equals 1, and then I'll go ahead and start plotting this. So always start off with your midline, so it's at 1, so we're going to have this midline right here. Then the next thing you want to mark off is the amplitude, so from there we got to go up 2, and then down 2, and then we put the shape on. So my shape goes like this. In a cosine, they start high and end high, so it's going to be here, and it's going to end here. The very, very center is the lowest, and then in between each of the pairs of dots, like on the first 2 right here, it's going to end up on the midline. And then in between these last 2, it's going to end up on the midline again. So this is what a cosine shape looks like. So again, domain is always negative infinity to infinity. The range is going to be from -1 to 2. And then it's a cosine shape, so we know that all cosine shapes are even. Okay, next one, amplitude. Amplitude is the number in front, but it can't be negative, so the amplitude is 1. The period, since it's just an x, it's always going to give us a 2 pi. And then our midline is at y equals -2. And I hope you notice that the midline is always y equals. So we go down 2, and then we mark off the midline. Now you're going to have to remember about that negative because it's going to flip the shape upside down. It's a reflection. So now we're going to mark off the amplitude. So we're going to go back up to -1 and then down to -3. And same thing as before, except instead of starting with the high point, it flips upside down. So it actually starts and ends low. So we got here, and then the center is going to be the highest, and then in between is where it's going to cross. So we end up with a smashed down shape kind of like this. So domain, negative infinity to infinity. Range would be from -3 to -1. That was supposed to be a bracket, by the way. And then it's a cosine, and all cosines are even. And same strategy as before. I'm only using the points down here on the x-axis. So that means that I'm not going to use this. I'm not going to use this. It's basically every other one. So at 0, we go up to 2. Pi halves goes up to 3. Pi goes back down to 2. Is that right? 2, 3, 2. Yes. And then we have 3 pi halves is at 1. And then 2 pi is at 2. So we have a shape like this. Now you can kind of tell what shape it is just based off of this midline. It's a sine shape again. So that means that the amplitude, since this point is above by 1 and this point is below by 1, the amplitude is 1. The period is the 5th dot across, so that's going to be 2 pi. Midline is the red line I drew, so that's at y equals 2. Domain is negative infinity to infinity, and then your range is from the lowest, which is this spot, and this is the highest. So it's from 1 to 3. And since it's a sine shape, it's supposed to be odd, but it's not passing through the origin, so it's neither. Okay, so complete the table for the graph below. List the transformations. So we know that a regular cosine has a midline at 0. So it looks like this shape has a midline at -1. So that means that it shifted down 1. We know that a cosine starts high and ends high, so it's not a reflection, so we're good there. And we know that the period is at 2 pi, so that's a normal period. So to write the equation, we would have to do y equals, we already know it's a cosine shape, so it's the cosine of x, and then since it shifted down 1, it's just going to be -1. Average rate of change. So for the average rate of change, you're going to do y2 minus y1 over x2 minus x1. So they gave you the x's, we just got to find what the y values are. So when x is pi, let's see, here's pi, the y value would be at -2. So that's my first point, and then the next one they want us to use is 2 pi. So at 2 pi, it's 0. So using the formula, I'll put y2 minus y1, which is 0 minus -2, and then it's going to be 2 pi minus 1 pi. So we end up with 2, because that's a positive now, over pi. So the rate of change is 2 over pi. And it's just the slope. That's what rate of change means. Okay, next, list the transformations. So we got to know where the midline is. So it looks like the midline is here. We've got the 3 dots on the midline. So it's already going up 1. I also noticed that the low point is in between the first 2 dots. Usually that's between the last 2. So that means that it's a reflection. That means that when we write the equation, there's going to be a negative in front. So it's going to be y equals negative. The amplitude, it still appears to be 1 because it goes 1 down and 1 up. So it's going to be negative sine. The period is still at 2 pi, so that means that we just put an x in here, and then we have to go up 1. Rate of change, again, from 0 to 2. So at 0, it's at 1. And then at x, no, not x equals pi, so pi is the next one. At pi, it's at 1 again. So using the y2 minus y1, we'll end up with 1 minus 1 over pi minus 0. And the bottom doesn't even matter because the top is 0, so that means that the overall average rate of change is 0. Okay, so we're going to list the transformations. So we got to figure out what's different about the shape. So they're both cosines, but this one now has a 2, and this one now has a number inside the parentheses with x. So the 2 is a vertical stretch. It changes the amplitude, so it makes it taller, so that's why it's a stretch. Anytime you put something with the x, it moves across with x, so that's either left or right, and then it's always opposite of what's in here, so this is actually right pi fourths. That's called a horizontal shift, and we don't usually graph those, but we just talk about them in terms of the shifts to the equations. Okay, next, sine. So it looks like the only difference is this, and since it's not inside with the x, that indicates it's not going to go up and down. Okay, it's 7 a.m., whatever. So if it's the number at the end outside of the parentheses, that's a vertical shift, and since it's negative, that just means it's going to go down 4. Next, the sine to the sine. So we've got the -2. So first, the negative is the reflection. The 2 is the stretch. And then the 2/3 is the horizontal shift, and this time it's going to go left 2 pi thirds. Let's see, we got the negative, so that's a reflection. We've got the plus pi, 3 pi, so that's opposite, so it's going to go left 3 pi. And I'm saying left and right in these ones because it's inside with x, and x goes across. And then you have your vertical shift down 6. Pretty simple. So now we have to apply these transformations. We want it to go right 3 pi and up 2. So the new equation would say 3 cosine x. So if I wanted to go right 3 pi, I would actually put minus 3 pi. If I wanted to go up 2, I just put plus 2 at the end. Pretty easy. This one is pi 6 to the left and reflection. So reflection is easy. Reflection just means put a negative in front. And then we want to go pi 6 to the left. So that has to go inside. Oops. That has to go inside with the x. So it'd be pi 6 in here. And since we want it to go left, we're not going to go negative. We'll always go opposite when we're inside here with the x. And then this already had the minus 1 outside. Okay, so write the equation that has the amplitude and the period. So amplitude is easy because that's the number that goes here. So we're going to start off with y equals 4 cosine. Now the problem is the period. If you could just memorize that the period, when the period is 2 pi, that means that b is equal to 1. So anytime you see a 2 pi there, you just put an x on the inside. So that's pretty easy. Now when it's not a 1, like in problem 16, that's when you have to do a little bit of math. So this one right here, amplitude, so it's going to be cosine of, not cosine, I want to put y equals 2/3 first, and then the cosine. Now, there's going to be an x in here, and there's going to be a number in front of it, and it's not going to be a 1 because this is not 2 pi. So what we're going to do here is we're going to put the formula for the period, 2 pi over b, and we're going to set it equal to what the period is supposed to be. It's supposed to be 16. So all we do here is cross multiply. So I put this over 1. I end up with 16b equals 2 pi. And so I just divide by 16. 16. And that gives me, what is that, pi over 8? So pi over 8 is what goes in here. Doing cosine and sine shapes, they're exactly the same. So y equals 5 sine. And then we're going to have something in here with an x. Now the thing is, I know it's not going to be a 1 because this isn't 2 pi right here. So I have to do the math again. So 2 pi over, oh, I hate when my mouth says something and my hand writes something else. 2 pi, what am I doing? 2 pi over b, third time's a charm. And the answer is supposed to be pi over 8. So we just cross multiply this. So we end up with pi b equals 16 pi. So we just divide by pi, not b. I want to know what b is. So that means b ends up being 16. So 16 goes here. Amplitude is 1, so that's pretty easy. We just put a sign, and then we're going to have the x over here. Again, we're going to have something other than 1 because this is not 2 pi. So I take 2 pi over b equals 12 pi. Put it over 1 and cross multiply. So I have 2 pi equals 12 pi times b, and I just want b by itself, so I divide by 12 pi. And so that's going to cancel, leaving me with 1/6. So I put the 1/6 in here. Amplitude, I'm not going to write these, I'm just going to tell you what they are. Amplitude is the distance from the midpoint, so it should be the same above as it is below, and you can find the amplitude in front of the sine and cosine in the equation, and it's never negative. What type of transformation creates a midline that is not y equals 0? That's a vertical transformation that's found at the end of the problem. It's never in parentheses. How do you find the period of a sine and cosine function given the equation? If you have the equation, you take 2 pi and divide it by b, and b is the number located in front of the x that's in the parentheses. Describe the differences between a trigonometric graph and a linear graph. A trig graph is a wave, and a linear graph is a line. Okay, the temperature in the office is controlled by an electronic thermostat. The temperature is varied accordingly by this function. Y is the temperature in degrees Celsius, and X is the time in hours past midnight. It says, what is the temperature at 9 a.m.? So how many hours have passed since midnight? So what that means is X equals 9 hours. So all you have to do is plug in 9 into the problem and then type it into your into your calculator. I'm not going to do that because my online calculator expired, so I'm going to have to purchase one or something so that you can see it in the videos in the future. But all you would do is in the calculator, you would just first make sure that it's in radians because this has a pi on it, and you would just put in a 9 right here. Whatever it spits out, that's going to be the temperature in Celsius degrees. How is the function shifted vertically based on the midline? Well, since it's a sine graph, usually sine graphs are have a midline at 0 unless there's a shift. And the shift, the vertical shift at least, is found at the end right here. So that means that it shifted vertically 19 units or 19 spaces on the graph. And that's it. That's the review for chapter 13. With that, you should know how to do pretty much everything on the test.